We start with, the first example. This is going to be a lot like dealing with the concept of an inscribed angle. Okay? So just to, give you an easier version of this, okay? If you want on the side here, I'm just going to draw a circle. Okay? And then I'm going to draw a straight line that is tangent. So it only touches the circle. Okay? All right. What's the measure of a circle? How many degrees? 360. Okay? What's the measure of a straight line? 180. So do you notice that the straight line ends up being half the circle? Do you recall that the inscribed angle is half the arc? Right? Okay? So all I'm going to do is I'm going to draw a secant, okay, that kind of goes through our circle. Okay? And so if I were to just randomly say that this is 240-degree arc, okay, the angle is going to be half that. All right, so would anybody be able to give me the measure of this arc on the right side or this angle? Yeah. The angle would be 60. Why? Has to equal 180 for a straight line. Okay, so what's the arc measure then? 120, because you would double that. Okay? Now, is 240 plus 120 360? Yes. Is 120 plus 60 180? Yes. So it works. Okay? So it's just like having an inscribed angle. The angle is half the arc. All right? So how can we apply that concept to this example over here with algebra? What's the relationship between the 9x plus 20 and the 5x? Mike?
5x is half of 9x plus 20.
Okay, so if I did that, 5x is half of 9x plus 20. Well, then I am going to end up with half of 9x being a decimal. Are you guys okay with dealing with a decimal?
You could also multiply the 2 to the other side to make it 10x is equal to 9x plus 20.
Okay, or we could double the angle, and that's equal to the arc measure. Okay, so if we, anytime you're in situations like this with variables, and I know variables sometimes can be confusing, think in terms of basic concepts. Like, for example, if this arc was 80 degrees, and I'm just randomly throwing out an 80 degrees, what would the angle have to be? 40. Okay? How do I go from 40 to 80? I double it. So I take my 5x and I double, and that equals the arc. Okay? But the way that I'm teaching myself that is by randomly using numbers. Okay? So always just change it into something simpler and then use that concept to create an equation. All right? So 2 times 5x is 10x. 9x plus 20. What does x equal? 20. Okay? So if x is equal to 20, I'm going to just plug that in over here. Okay? What's 5 times 20? 100 degrees. What's 9 times 20? Plus 20. 200. Did it work? The angle is half the arc. Questions with that? All right, so like I said, just as a quick review, it's just like dealing with the idea of an inscribed angle. Okay? All right. Next, we're going to deal with a situation in which your angles are inside the circle. This is what we call like a chord situation. Okay? You have 2 chords intersecting, and we're going to try and find the angle in between. Okay? And then you have to kind of understand, well, which angle are we trying to find? So I kind of talk about this idea of like a bow tie. If I were to take the arc that has the number on it, the arc that has the number on it, okay, and then connect the 2 chords, I create this little like kind of red bow tie. Okay? So it's always the angle inside the bow tie that we're going to use. Right? And the way that we're going to do this is we are going to simply do arc plus arc divided by 2. We're going to find the average of the arcs. That's going to give us the angle inside. Okay? All right, so if we do that with the numbers we're given, 120 plus 98 divided by 2. What do you get? Should it be a number greater than 120, less than 98, or in between 98 and 120? What'd you get?
109.
She got 109. Anybody else? 109, 109, 109, 109. All right. So angle 1 is equal to 109 degrees. Okay? All right, so other things that we should be able to do. Can anybody tell me what this angle is next to the 109? What is it? Y 71? Has to equal 180 because you got a straight line. The one opposite, you should understand, is also 109, and this one is also 71 because of vertical angles and supplementary angles. Okay? All right. Next question. Is where these two chords intersect the center of the circle? Katie, why are you shaking your head?
Oh, there's no dot saying that there is.
Okay, there's no dot that says there is. Can anybody give me another reason? Using numbers, possibly. Okay, well, what do we remember about central angles and the arc? Part of the reason I'm asking the question is just a review question. What's true about the central angle and the arc? Like, what I remember, central angle is when it is at the center. So like, if this was 72 degrees, what's the measure of the arc? 72 degrees, right? So, is that working in our picture? Is 109 equal to 98? Is 109 equal to 120? No. So therefore, it's obviously can't be the center, okay? So this is a different situation, all right? All right, so the one below. See if you can figure out the measure of angle 1, and then we'll go on to example 2.5, okay? So see if you can figure out the measure of angle 1. Try that one. Understand, okay, is, and this is why I kind of talked about like that bow tie idea, okay? We want to find, when we go to do our little formula, when you go to do your 53 plus 41 divided by 2, you're finding this angle, the one inside the bow tie. Okay, and did you get this angle to be 47? So what's the measure of angle 1? 133. So Austin, you were correct. Okay, good job. Okay, so you had to understand that you're finding the supplement. Okay, all right. So be careful. Make sure you understand which angle you want. Okay, so let's go on to example 2.5. All right, this one we'll do together. So what you have to understand is they give me this arc and this arc. So when I go to use my little formula, I need this angle. What's the measure of that angle? What's the measure of this angle next to the 102? 78. Perfect. Okay? So when I go to do my formula, I'm going to do y plus 95 divided by 2 is equal to 78. Okay? Because this is the angle in between the two arcs. Okay? And in between the two chords. Okay? So there's my little bow tie. All right? How do I solve for y? Ideas. What do you want to do?
You multiply both sides by 2.
Multiply both sides by 2. Okay, think about it this way. You could do the idea of cross multiplying, and that's why we're multiplying by 2. Okay, however you want to look at it, the reason we're multiplying by 2 is it cancels the 2 in the denominator, leaving y plus 95 equal to a 78 times 2. Hopefully you get 156. Subtract the 95. What do you get? I heard 61. Y is equal to 61 degrees. Okay? So if this is 61, make sure, again, you understand, since we're trying to find the average, the sum of two numbers divided by 2, this should always be in between. So if 95 is bigger than 78, I need a number less than 78 when I go to, when I'm done, okay? Right, questions there? And then don't forget, basic math, okay? You could have simply just done 95 minus 78, and then 78 minus the same amount gives you 61. You could have done that too, okay? 95 minus 78 is 17, 78 minus 17 gives me 61. You okay over there, Andrew? What are you frustrated about? So if I were to look at this example here, okay, look at the chords creating a plus sign. So that reminds me that I want to, add the two arcs together. But when I, okay? All right, page 2. All right, so now what we're going to do is we're going to talk about the second possible formula. And that deals whenever we have a secant, secant, secant tangent, or tangent, tangent. Okay? So the three possibilities. Okay? Secant, 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 and a tangent. And then a tangent and a tangent intersecting. Okay? All right? And the tangent, tangent one, I'm going to show you an easier way. Okay? All right, so for this one, using example 3 as our, way of teaching it, it's always going to be the big arc minus the small arc. That's small, SM arc, divided by 2. Okay? So just to show you something, if I were to go is I'm going to do 108 minus 34 divided by 2. So what's 108 minus 34 divided by 2? What'd you get? 37. 37? So angle 1 is equal to 37 degrees. Okay? All right, so the one next to it. In order to do the big arc minus the small arc divided by 2, I need to know the measure of the small arc. Ideas? Anybody know what that blue arc would equal? Mike?
117.
117. How'd you get 117, just in case other people don't know?
So you have 243.
Uh-huh.
You gotta take the sum of the entire circle, which is 360.
Yep.
Subtract 243 to get 117.
Okay, so the 117 comes from 360 minus 243 because the two arcs form an entire circle. Okay, this is a tangent-tangent situation. Notice the two black lines are both touching the circle. Okay, the one on the left was secant-secant because the two lines are going through the circle. Okay, so this is the one that's going to end up having a special case. Okay, so now when we go to calculate the measure of angle 1, we do the big arc, 243, minus the small arc, and then divided by 2. What do you get for the measure of angle 1? 63 degrees. All right, so ding, 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 ding. Does anybody see a relationship between any of those two angles? Does anybody see a relationship between any of the three numbers presented up here? What do you see? Which ones form 180? The 63 and the 117? Very good. Okay. So, new concept, okay? You can always use big arc minus small arc divided by 2, but anytime it's a tangent-tangent situation like you see here, if you know the measure of the small arc, it's always 180 minus the small arc. Always. 100% of the time. Okay? That doesn't mean you can't do the other formula. You can still do it. Okay? So, to just kind of check for understanding here, if I were to do the following situation, here's a circle. Okay? Here's a tangent line. Let's make that a tangent so it touches. Tangent line so it touches. Okay? And if I were to say that this angle right here was 50 degrees, what's the measure of this arc? 130, because they would add up to be 180. Okay? And then you could always find the measure of the big arc by doing 360 minus 130 and getting 230. Okay? Questions there? All right, so now let's make it a little bit more difficult. Let's look at the example over here, example 4. Okay? All right, ideas. This is a tangent line and a secant line. So we're using big arc minus small arc divided by 2. So are you okay with doing 4x plus 5, that's the big arc, okay, minus the small arc, 50, divided by 2, equals the angle x plus 2.5. Again, the big arc minus the little arc divided by 2 equals the angle. Would you be able to solve that? Try it. Okay, remember, first thing we said was multiply by 2. Okay, I'm going to multiply this entire thing by 2. Okay, that's going to give me a 4x minus 5, plus 5 minus 50 equal to a 2x plus 5. 2 times x, 2 times 2.5. That gives me a 4x minus 45 from 5 minus 50 equal to 2x plus 5. Would you be able to now solve? Subtract 2x over, you get 2x. Add 45 over, you get 50. What's 50 divided by 2? 25. So x does equal 25. Okay? So it's just same concept, big arc minus little arc divided by 2. Okay, just incorporating some variables there. All right? So if I help you set up the bottom one, see if you can do this one. Okay? So it's going to be the big arc minus the little arc. Okay, so 13x minus 6 minus 5x plus 14. Parentheses is super duper important here. Divided by 2 equals the angle, 54. Okay, see what you can do. Do 13 minus 5x is 8x. Negative 6 minus 14 is negative 20. If you had positive 8 there, that's why you're getting 12.5. And then when I go to multiply the 2 to the other side to cancel it out, okay, I get a 108. Add the 20 over, divide by 8, and x should equal a 16. Okay? So it's just a couple of review of, a little bit of review of algebra. All right?